An object from another star system just passed through our solar system, and the latest images could rewrite everything we thought we knew about the universe. An object from another star system is passing through our solar system, and the latest images are unlike anything scientists have ever seen. 3I Atlas isn't just another icy rock with a tail. It's only the third confirmed interstellar object ever observed, joining the ranks of Oumuamua and 2I Borisov, making its discovery one of the rarest astronomical events in modern history. What makes this object so fascinating isn't just its origin, but what the latest images are telling scientists. Multiple space telescopes and missions, Hubble, NASA's MAVEN, and high-rise cameras, ESA instruments, and even independent ground-based observatories have captured 3I Atlas up close as it journeyed through the inner solar system and now as it speeds back into interstellar space. The first thing that stood out in these images is the comet's distinctive shape and structure. When Hubble tracked 3I Atlas in mid-2025, it showed a teardrop-shaped cocoon of dust streaming from its nucleus, with stars streaking in the background, because the telescope was following the comet's motion. This alone was striking. The dust envelope looked unlike many comets we've seen in the solar system. Then came images from NASA's Mars orbiters. The high-rise camera aboard the Mars Reconnaissance Orbiter and MAVEN's ultraviolet sensors captured composite images showing halos of gas and dust, giving us a view of how sunlight is breaking apart the comet's ice into hydrogen and other particles. These images go beyond beauty. They give data on the chemical and physical processes happening in real time. But now, the latest 3I Atlas images are raising even more questions. High-resolution observations show that its jets, the streams of gas and dust shooting off the nucleus, are not behaving as expected. Instead of forming a smooth, uniform tail like a typical comet, 3I Atlas shows complex jet structures that wobble or shift over time, hinting at unusual rotation or surface activity we've never seen before. This is scientifically huge. Every comet from our own solar system forms tails because ice sublimates, turns directly into gas when heated by the sun. But interstellar visitors have spent eons exposed only to cold darkness, with chemical compositions shaped by environments far outside our system. So by observing how 3I Atlas reacts to the sun's heat, scientists get a once-in-a-lifetime look at the building blocks of other star systems. What's more, these recent images show multiple tails and jets emanating in different directions, not just the classic single tail you learn about in school. In some captures, dust and gas appear to be streaming toward the sun, forming what scientists call a sunward anti-tail, an effect caused by perspective and particle behavior that most comets don't exhibit so prominently. The diversity of instruments capturing 3I Atlas also offers scientists a multi-wavelength view, from visible light to ultraviolet wavelengths, each revealing something new. For instance, ultraviolet observations highlight water vapor and hydrogen emission, helping researchers estimate the comet's outgassing rates and surface activity. On top of that, Earth-based surveys and amateur astrophotographers have contributed breathtaking wide-field images of 3I Atlas as it crosses constellations and races away from the sun after its closest encounter. These public images provide context that complements the high-resolution shots from space telescopes, showing the comet's evolving tail and motion across the sky. Now, why does all this matter? Because these images are more than just snapshots. They're evidence of an object that formed around another star system billions of years before our own. Its behavior as it interacts with solar radiation gives astrophysicists clues about conditions in distant stellar nurseries and the chemical evolution of interstellar bodies. Here's where it gets even more compelling. Some researchers have suggested that the structure and activity of 3I Atlas don't fully match what we'd expect from a typical comet, even one formed in another star system. The wobbling jets and multiple tail configurations hint at physical processes that might be unique, or at least extremely rare, compared to everything we've studied locally. But before anyone jumps to wild conclusions, scientists are careful to separate data from speculation. NASA and ESA officials have emphasized that although these observations are extraordinary, the behavior of 3I Atlas is still comprehensible within known physics. It's just that the environment it formed in may have been very different from our own, producing unexpected features. And yes, there are fascinating theories out there, from cosmic chemistry to highly complex cometary structures, that could explain these images. Some hypothesize that regions of concentrated activity on the comet's surface are driving the unusual jets. Others believe that rotation and uneven heating may be reshaping its tail dynamically as it swings away from the sun. This isn't just astrophysics nerd talk. These new images are helping rewrite the textbook on what it means for an object to be truly interstellar, not just coming from another star, but shaped by conditions no probe or mission has ever sampled directly. What's next? 3I Atlas continues its outbound journey, heading back into the darkness between stars. But as it drifts away, telescopes across the globe and in orbit continue to collect data, feeding scientists more information that will likely be studied for years to come. Astronomers are particularly eager to see how the comet's jets and tails evolve further from the sun's influence, offering comparisons between its behavior near perihelion, closest approach to the sun, and in its fading light. This may finally help answer whether the unusual features captured in recent images are intrinsic to its nature or responses to solar pressure and heat. These new 3I Atlas images could indeed change everything in how we think about interstellar visitors. They give us high-resolution, multi-angle looks at an object formed somewhere else in the galaxy, possibly billions of years ago, and now observed in unprecedented detail as it travels through our solar system. It's a rare chance to study a cosmic messenger from another star system, an opportunity that bridges worlds, challenges assumptions, and expands our understanding of the universe. And as telescopes keep their eyes trained on this remarkable traveller, we're reminded that even in the vast darkness of space, unexpected discoveries are always just one image away. These images of 3I Atlas could change everything we know about interstellar objects, and the universe may never look the same again.